Okay, so we're going to look at controlling air pollution. Look at air pollution that comes from a combustion engine, in particular a car combustion engine. There's three gases in particular that we look at. Carbon monoxide, oxides of nitrogen, so that could be nitrogen monoxide or nitrogen dioxide, and unburnt hydrocarbons. So all these can come out of the exhaust of a car engine from the combustion engine. So first of all, looking at carbon monoxide, it comes from the incomplete combustion of hydrocarbons. It's when there's not enough oxygen present when the hydrocarbon inside the engine, i.e. the petrol or diesel, is being burnt, being combusted. There's not enough oxygen present, you get incomplete combustion, and that leads to carbon monoxide being formed. This is a big problem because it's a poisonous gas. What the carbon monoxide can do is bind to the hemoglobin in your blood, stopping oxygen being delivered to where it's needed throughout the body. We get oxides from nitrogen because in the combustion engine it obviously gets very hot, and in the air it gets fed through to cool the engine and supply the oxygen. There's obviously a lot of nitrogen as well in the air. 80% of the air is nitrogen. So this nitrogen, as it gets hot inside the combustion engine, can react with oxygen and be oxidised and form either nitrogen monoxide or nitrogen dioxide. So that's why it's called oxides of nitrogen. It could be more than one. Sometimes you say it as NOx. So problems with this then. It can cause low level ozone. So ozone at our level is a problem. It can particularly be bad for asthmatics. It can cause a lot of breathing issues. NOx, as in NO or NO2 themselves, can cause respiratory problems. They're an irritant as well. And the nitrogen oxides can convert to nitric acid once they're in the air, in the environment, and that can cause acid rain. Okay? Unburnt hydrocarbons, so sometimes these are called VOCs, volatile organic compounds. So they're compounds that have gone through the engine and for whatever reason they've not been oxidised, they've not been combusted, and they've come out in the exhaust. Examples of this can be benzene or buta-1,3-diene, and these two are particularly nasty because they're carcinogenic, which means that they can cause cancer. They also cause low level ozone, which again causes breathing difficulties. So, what can we do about it? Well, unburnt hydrocarbons are quite easy to solve. We just need to supply more oxygen to them to make sure they're fully combusted before they leave the engine. How we look at these other problems though is that we use a catalytic converter. Okay, so a catalytic converter is that's also a catalyst. And that catalyst is a kind of mixture of platinum, rhodium and palladium, so precious metals. They're not cheap, it's quite an expensive part of the car. And they tend to be on a honeycomb mesh. The reason for this is, rather than just be a solid block, they have lots of pores in them, and that increases the surface area, so there's lots of sites for these gases to react on. So how do they work? If we look at the case of carbon monoxide and nitrogen monoxide, the first part of the process is that these gases are adsorbed onto the surface of the catalyst. Adsorption. Notice that's spelled with a D, not a B. It means that they bind to the surface, not absorbed into the structure, they're stuck to the surface, absorbed. Okay? Now that adsorption has got to be quite weak, but it's got to be strong enough to cause these bonds in these gases to break and a chemical reaction to occur. And then that can make CO2 and nitrogen, and then these gases are deabsorbed. We don't want them to be bonded too strongly, otherwise we won't get deabsorption. So the gases that are produced are deabsorbed, and carbon dioxide and nitrogen from the catalyst are removed from the surface by deabsorption. So you get adsorption of the reactants, the chemical reaction, and then deabsorption from the catalyst. Okay. So what's happened then overall? We've taken our nitrogen monoxide and our carbon monoxide, and we've caused them to react together to make nitrogen, which is harmless, 80% of the gas already, and carbon dioxide. Yes, carbon dioxide is a greenhouse gas, but it's a lot less threatening than either of these two. Okay, so how can we check that this is working? Well, you take your car, it has to be MOT'd, and they'll do an analysis of your exhaust. We can also take samples of air from cities and towns to see what pollutants are about. And how do we analyse that? We use infrared spectroscopy. So these different gases have different types of bonds, and we can look at the vibration of the bonds to work out what gases are present in the sample of air. Okay, so we can monitor air pollution and monitor car exhaust using infrared spectroscopy.